Yeah, exactly. Okay. So again, my name's Jeremy. Some people call me the dude. I don't know why. A little history about me. I came from New York. If you notice, I don't have a Swiss accent. I spent about 10 years in New York, right at the time of the internet boom. And I started a company with some friends, and we did a lot of websites and games and CD-ROMs. Anybody remember CD-ROMs? And then I was there for a while, and I closed that company in 2002. I actually was a freelancer for many years. And in about 2006, I discovered Rails, and there was the very first conference was in Chicago, and that was quite something. I saw David Hanmeyer Hansen announce REST, and everybody was like, "What's that?" And that was pretty interesting. And then around that time in the fall, I moved to Switzerland. My wife is Swiss, and so I came here to live and work. However, I was still doing all of my work in New York. And so I traveled around, did a lot of conferences, worked on some startups, worked on a lot of different projects with friends and things. And it got pretty tiring, and I had a daughter. So I decided it was time to work in Switzerland. And about that time, I got this email. Many of you probably know Georg, who worked here. He was responsible for bringing Rails to Local. And so he sent out an email saying that we're migrating the old PHP front-end code to Ruby on Rails. And I thought that was pretty interesting, so I just replied and said, "How about me?" And so I went in for an interview. And now we come to a brief history of time of Ruby at Local. So we go back a little bit. And at this point in time, we were on a code base that was just growing and growing and growing and growing. I actually did a code analysis of it. I had the old front end on my laptop. And there was quite a lot of stuff in there, and it was templates with embedded logic and a lot of custom things. It was a kind of a difficult release process. I personally feel, having worked on a lot of projects with XML, that it can be awfully heavy. It's so simple, and it's, we think of HTML, but there's so much under the hood, parsing it and everything else. So maybe not for developing websites. So Local needed a way forward, but they also knew that rewriting the entire website was really not an option. And that brings us to the first thing that we learned early on, which was don't try to do the big rewrite and to do it in pieces. Now, Ruby was actually around at the time. There were several people here that really liked it, and it was being used for scripting and deployment. There were rake tasks. And so the web team decided to do some hack projects to see what they could do, and they decided to embrace Rails. And the reason that Rails was interesting for them was because it really provided some standards about how to do things. So much that was done in the past was invented here. And that was a problem for them. When new people were hired, they had a lot of work to do to kind of get up to speed with the tools and the in-house way that things were done. Rails gave them a framework to actually do things in a standardized way. And so the migration was done in steps, and this is kind of a rough outline about how it was done. The very first thing that was picked off was the map. Map.local.ch gets probably the least traffic of the various other sites that we run. And so it was a good test to see what could be done. So the map actually was an effort that started out as a spike. It was the first live Rails site at Local, and it was kind of an experiment, but it proved that Rails can work. And surprisingly, it didn't take that long to build. Within a couple of months of deciding to do it, there was something that was actually working with tests, and it was actually functional. Eventually, the next step then, right at the point when I joined, which was in the fall of 2011, was rebranding and moving just the home pages. So the decision was made, okay, let's not try to port all of the business logic and everything else. We'll just do the home pages. So the home pages were done in Rails. They were just kind of like static pages, basically. In fact, we even cached them statically. But on the back end, what happened was the main forms and the advanced forms just submitted back to the actual PHP old front end. And so there were some design updates that were done to the old front end to make it look a bit better. But essentially, we were running both platforms simultaneously. And And this was another point that I think was a good learning lesson, which was to invest in a good load balancer. None of this would have been possible without a really nice load balancer. And we're lucky that we have an incredibly cool load balancer. It lets us do scripting. We can organize things into pool, balance between data centers, failover, all of these kind of things. But it really proved useful in doing little hacks. Like, for instance, if you wanted to download a V card on your phone, well, we didn't write that part in Rails. In fact, we still haven't written that part in Rails. And it goes to the load balancer, and the load balancer sneaks into the old server and does that one little function and returns it. And that way we can kind of like slowly migrate things so legacy can be done later. At that point, there was a lot of work that was being done on actually trying to get the full front end to work. So we focused on doing the what's called the result list, and we created a beta site. The beta site basically looked like this. It's very similar to what you see now. This was one of the first versions. And we stuck a little beta up there, which was kind of cheesy. And then we had a bar across the top. So what happened is if you went to the site and you saw the teaser that was on the front page and you clicked on it, it would set a cookie that told us that you were a beta user. This let us measure like how many people were actually going to the site, but it also let us give them the option to say, you know, I want to keep using the beta site. And it was actually pretty successful. A lot of the people that tried it out decided they wanted to keep using it. They didn't know it was Rails, but it was, you know, a newer, fresher design and a bit simpler to use, we hope. Then the next thing that came along that was pretty cool is how do we start migrating this traffic? So we didn't want to just turn Rails on and just have everything hit it at once. In fact, we weren't even sure that it could handle it. So Jonas actually came up with a brilliant idea one day, which was, why don't we do it by browser? And we were struggling quite a bit. Like, the design was fairly involved, and we had to test on all the various different browsers, and we had it working really well in Firefox, because that was what we were using for development. So we did a check in the load balancer again to see what kind of user agent the user was coming with, and if they were on Firefox, we'd send them to the beta site. If they were on another browser, we'd send them to the old site. This allowed us to slowly migrate people bit by bit. Here you can see around April, in the beginning of April, we first started moving people over, and it was very gradual, but it was, you know, a lot of traffic since we were still kind of unsure. And as things were going pretty well, we began moving more and more browsers until eventually the last browser we moved was IE6. And web to manage string. So then this, then that was April 12th, and the beta site was live. No more traffic was really going to the old front end, except for a few little functions here and there, but that was pretty much it. So now I go to the second part of the topic, which gets a bit more technical, and this is what we learned. The first thing we learned was to keep things simple. And you hear this a lot, but I'll give you a specific example. How many people here know Ruby, actually? No, you guys do. Okay, so here's an example of, this was when I first started, Local had written something that actually is really cool. I mean, it was cool. It was this mapper, and the idea was that we got these really big XML responses back from the search engine. And so the idea was that you could map them because we were using back-end REST services. We didn't have a database, but we wanted to work with models. So the idea at the time was, let's create a mapper. So the mapper would basically say, okay, I've got these properties. It would map to the XML. I could reference XPath to say, here's the author, which is an attribute. And I would get back an actual object that I could treat kind of like an active record object or a database object. And that was really cool, except often when you're parsing a response, you know, what you need for your model might be here, but then you might need this little bit down here. And when you have this kind of magical mapping happening, how the heck does that work? Especially because when you're parsing things with XML, it can get quite slow, and I'll get to that in a second. In the end, what we realized was, even though this was clever and clean, this was not that bad. And this on the right here is plain old Ruby. There's no magic happening whatsoever. It's just plucking values out and putting them into a model. And this is kind of the way that we do things now. So I think one takeaway from this was that API responses are documents. They're not databases. It's okay to parse things manually, and just because you're saving code when you're refactoring, you might have less code because of an idea you have refactoring, it doesn't mean that it's going to be better code or more maintainable. In fact, you may end up adding a lot of complexity. And so again, mapping is for records, not for API responses. The other thing we needed to do is we had a lot of performance concerns. We definitely didn't want to launch the Rails site and find out it was much slower than the PHP site. We wanted it to be even faster. But we wanted to test with real traffic. And one of the ways that we actually decided to do that was real traffic by looking at our logs. How many people have done maybe log replay or used tools for that? A couple people. So basically the idea behind log replay was to take our actual server logs and we wrote some scripts. And what we did was we used this really cool tool called Splunk. And Splunk basically does real-time parsing of all of the server logs that come in from the data center. And you can filter, you can sort, and so, for example, you can say, I want all the requests to the phone book search that resulted in a 200 response code on this particular browser or something like that. And we made ourselves these large sets of log responses that represented different components of the application. Then what we did was we had some simple tasks that would allow us essentially to do two things. One was to run a performance test, which was repeatable. Every time we ran it, it was the same request in the same order. And we had something called check URLs, and this basically went through a huge amount of URLs, sometimes tens or hundreds of thousands, and would verify, looking at the logs, I expected this to be a 200 or a 301 redirect, what actually happened. So in the case of doing the performance runs, after you ran all of these things, this is using HTTP perf in the background, and the actual scripts to do this were only, I don't know, 20 or 30 lines of code. So there was run this stuff and then display the results at the end. You can copy and paste this block, which had little tabs in it, paste it into Google Docs, and start to keep a log of how things were going. And so along the way, every time we made a major change, we would push this data in and actually see how things were doing. We could compare this to the existing front end and see if we were okay. The check URL thing, on the other hand, would let us see, did we really change things? And obviously for us, being a large site, SEO and how Google indexes us is extremely important. So we wanted to make sure that we didn't like screw up and return a bunch of 400s or redirect when we're supposed to be redirecting. So we saw a summary of what the stats were on each of the sections. So in this case, I was expecting 200s and I got a bunch of redirects. The other thing that we learned along the way was the extreme end of this, which is over-optimization. Back to the giant XML messages. I mean, XML can be really cool, but like this is just like a third of the response we might get for a really complicated search with a lot of metadata. And it can be very slow. And we became concerned about this because in our synthetic benchmarking and our initial tests, we saw that things weren't going, and we began to look deeper and deeper into the problem. These are snippets from actual emails. And for about a week or two, we were just focusing on trying to get this faster and faster. And it was quite fascinating. I mean, we got into stack dumps and profiling and low-level optimization. And in the end, we actually did manage to get it fast. We sped it up about twice as much. But looking back, I'm not sure it was really worth the effort because, you know, things change. And so I guess the lesson here is that you know, being ready for change and not focusing too much on premature optimization is important. The next topic is testing. And testing is, as you know, is hard. In the beginning, we were using Cucumber. And Cucumber is really great at describing things in a way that people like managers can understand. The problem where we struggled with this was that these were often driving browser tests that were slow. And under the hood, we had these steps. And the steps, if they weren't organized right or they began getting bigger and bigger, it became pretty much unmaintainable. And what we ended up finding was that we did a measurement of the amount of time that we were spending on various tasks while we were developing the beta site. We were spending more than half of our time actually fixing and running tests as opposed to writing new code. In fact, here's a summary of our code base from a couple weeks ago. And it's kind of impressive that we're under 3,500 lines of code for the main app. There's some gems and some other things in the back end that do the data modeling. But the test lines of code is twice that. And that might be something to be proud of, but in actuality I feel like it's not, because it just means that you have twice as much test code to parse and understand. So now we're kind of struggling to get back in the other direction, to recover from huge amounts of tests, to try to bring back things, to try to keep it in a way that we can write the tests, run them, change them quickly, and refactor without really having to get stuck. And for a while we had continuous integration, but we're still working on kind of getting to the point where we can trust that. And you know, for the most part, our tests cover us, and we don't have a lot of operation. So the other thing that was kind of cool that we learned was deployment. Deployment was something that was painful in the early days. It required a packaging step, and you have to like drain the servers from one data center and enable them in another. Rails gave us some really cool ways that we could push out the code to the server. And using Unicorn, it would restart seamlessly, and we wouldn't lose any traffic at all. Along with that, we created some environments. So what we would actually do is we would push things out to a dev environment, which was on a dev server. We could run our log replays against it, we could test it, let people in the company see it. Then we could push it out to eventually beta, where people could actually play with it, and then production. And so this pipeline kind of gave us a way to deal with that. And then we wrote some custom deploy stuff that actually let us do, actually there's nothing custom here, that actually let us do some nice things, like we can check the current revision to see if the one that we deployed is the same. And a lot of tasks like that. But the other part was the deploy checklist. So we had a list basically. So when we were deploying, it was often that things could go wrong. Like you forgot to change a setting, maybe you didn't check Internet Explorer, whatever. So we got into the habit, which we still do it, and it's kind of fun that you do this manual checklist. You got to go through all the steps, check it off, and then you sign it, you put the date, and put it on the desk, and everybody knows that deploy is done. A big challenge for us was SEO, and as I hinted to before, when we launched the new site, we had a lot of trouble with SEO. For instance, robots.txt was blocking the phone book, the actual yellow pages. Once we discovered this, and we had, what was it, 150,000 something at one point, pages blocked, and Google was throwing all kinds of alerts and things like that. And then we fixed it and it recovered. And then we basically had a lot of issues with this, and one of the side effects was that we were on top at the beginning of the year, and then our biggest competitor suddenly passed us while we were having a whole lot of trouble with analytics and how we were configuring things. Once we recovered, though, we really recovered. We got the speed up, we got the SEO really right, we did the proper redirects, we did the proper tags and everything that we had to do, and verified that it worked. A big piece of what made us more efficient, and we got a lot more efficient as we went along, was heavily using GitHub. And GitHub is great. The best feature for us is the concept of pull requests. So each developer works on their own. They build a feature, and when they're done, we actually have a rule that we always put a screenshot and try to describe it a little bit better, like what the feature was. And then we do a code review. So once you've actually submitted the pull request, somebody on the team does a code review, they make comments, and this enforces that we're following standards, that our quality is good. And there's another side effect too. A non-technical manager can get emails from this, and they can instantly look at it and see what's going to happen, what's going to change. So it really reduced the amount of friction and communication we had with management as well. So this has proved really successful in being able to do that. And at any given point in time, we might do 1 or 2 deploys a day and have 5 or 6 pull requests open for review. A big cultural shift that also happened was while we were doing this performance stuff, we became obsessed with graphing. It was amazing that in the end of 2011, it was hard to tell what was actually happening on the website. We had a few tools where we could check things, but it was pretty ghetto. We got really heavy into graphite, and this is a shot of our info screen upstairs. And this has been, we've perfected it over time and refined it. We always have the right amount of information on the screen that you can look at it, and in 5 seconds is the site working well. Here we have the main response codes. This tells us, the green means are regular 300s. Each one is a data center, the 2 colors. The redirects, the 400s, and over the days and the months that pass, you get used to seeing this, and you can immediately say, hey, something's wrong, like the redirects are way too high. We came up with a really interesting way to capture JavaScript errors and graph them as well. And here we see the actual number of server processes that are running at what time, and network and server load, etc. One of the problems was StatsD and Graphite are actually quite hard to set up. And we worked across teams to try to get it working. It took quite a lot of effort, but it was totally worth it. If you ever have to do this, let me know, because there's a whole lot of ways that you can do it. There's different options, different forks of different projects. But Graphite and StatsD are totally worth the effort. And there's actually some outsourced services as well that do this quite nicely. We started to see patterns, like for instance, every day we have what we call the double dip. And this is basically when people get up in the morning, they start looking up numbers and addresses and everything, and then, just like clockwork, they go to lunch. They come back, there's another dip, which is usually a little bit less in the beginning, and then it drops off at night. This is, if we don't see this, we start to worry. Here's some more interesting little things that happen. On the back end, we used Redis to do some caching earlier, and this immediately showed us the effect of caching. As soon as we enabled the caching, we see the key hits here, we see the reduction in the lookup times on data. I mentioned earlier that we use Unicorn for hosting, so we came up with a way to monitor how many Unicorn connections were active at a time. So we could, across all of our servers, how many active sessions there were, and this is a scale thing, so we knew if we were reaching our capacity. If we saw a red peak, like here is quite a massive one, almost to 400 clients. The red means that requests are getting queued, that there's actually not enough bandwidth to handle it. Here's another example of when something goes wrong. So looking at this screen, I could tell, wow, that's weird. 20,000 requests, like just suddenly out of the blue. And oh my gosh, 12,000 redirects, like what the heck is going on? Well, it was something like that. All of the assets and images for the site were actually accidentally being routed through the application, which was causing each one to be handled as a request. So these are the kind of things where graphs really let you see where you're in trouble. Another challenge was external integration. So we have a lot of sites besides Local.ch, including like a blog and information and stuff. And you might update an asset on one site and then something else happens. You could write a test for this, but you might not find it. So these are the kind of things to check. We actually have a really cool solution for this that I can talk about afterwards that we're doing now to standardize all the look and feel on different sites. Here's another example. We had an incident where our load balancer, it has something called health checks. So you have 2 data centers and it's pinging the apps and saying, are you alive, are you alive, are you alive? And where do you tell it to do that health check is very important. And if you suddenly change something and you don't realize it, like in this case it was a language redirect. So it said, oh, you don't have the cookie language, I'll redirect you. And the load balancer goes, oh, all the servers are dead. So it shut them all down. And then we went, oh my God, that's what happened. So then we turned them back on again and it goes, oh, I'll shut them down again. And literally there was just no traffic at all. So that was quite terrifying. When we were doing all this performance optimization, we struggled a bit with virtual machines. I mean, we definitely embrace virtual machines for their flexibility. We use them for a lot of services and things, but running on the main website, nothing beats the bare metal hardware. And in testing, we found that it was by about 2 to 1, we could beat virtual machine speed on the same hardware just by using bare metal. We used Puppet for all our deployment and configuration stuff, so that made it easy to say we put in a new blade, initialize it for Rails, add it into the load balancer, and we're good to go. I think external, like we have a lot of tools internally, but external monitoring tools are really important as well. For example, we use New Relic to monitor like what our servers are doing, so we can see, for each server what it's handling right now. And this is important because we've done a lot of testing and we've had incidents. Like for instance, if the actual monitoring machines or graphing services go down, then we don't have any way to see what's happening. So this is often a way for us to get a second opinion about what's going on, or to see historical data. It's also good for optimizing in a way that you often can't do with something like Graphite, because New Relic actually plugs deep into your application. It works with more than Rails, and here we did a nice optimization to reduce the back-end requests that we had, and we actually saw, you can see immediately what happened. You can see the external stuff and the Ruby time and everything like that. Another service that we use is Airbreak. So when there's an error on the site, we get an exception about it. And we can know immediately like what it was, and we can go back and check like did we actually fix it. So the next time that we do a deployment, we can see what was the change. I actually took a screenshot today, so we have a few things to deal with. So that was actually quite fast, but that's pretty much it. Just to summarize the points that I think were kind of important. If somebody has some questions about Rails specifically, or our setup, or how we do stuff, I'd like to set the teams here, and yeah, thanks. Or have a beer.
What was the glorious optimization?
Okay, so we discovered that we were actually doing 2 requests instead of 1 on the back. There was like a double request happening. We were like, wow, this is so slow. And then we saw there was like a line of code duplicated. That's not so great.
Quick fix.
Yeah, exactly. It was a quick, very quick fix.
I've seen some numbers, so 100,000 lines of PHP code and 3,500 lines of Ruby code. That's not all Ruby. It's not equivalent functionality, or it is.
It's hard for me to say because I wasn't involved in the original front end, but it was a lot of that is including framework. So if you were to be fair, you would probably need to count all of the lines of code that actually were included in the Rails framework itself. I would be willing to bet that the total would still be less, but I didn't know that for a fact. I don't actually know that for a fact. I mean, I've worked on a lot of large Rails applications, and actually 3,500 is pretty good. I've worked on some apps that were 20,000 and more, and so it's pretty compact. But again, we have a ton of really cool technology on the back end with our search engine and things like that. So our Rails is basically, our app is consuming the API from the back end and rendering pages. So it's not really a complex app. There's a lot of testing because there's a lot of business rules and how these things are displayed. But it's a fairly simple app in the end.
When looking for Rails developers, did you try to look for Rails developers, or did you train people on the job? Did you get PHP developers and train them to do Rails?
I'm actually glad you asked that. I mean, in the beginning, the first year that I was here, we tried looking specifically for Rails developers and going to conferences, and what we found was that most of them were freelancers or they had a startup, and that made it kind of difficult. However, we did run across a few people. The surprising thing was, actually, the last couple of people that we hired who've been fantastic didn't have really specific Rails experience, and or they didn't know our systems, our apps, they could sit down and immediately figure out what was going on. Rails is pretty well documented at this point. There's a lot of books, and the standard practices are very similar to what you find in other frameworks. So actually we've had really good luck at hiring lately in terms of being able to find people. So I think the stigma, it's important if you are hiring Rails people that you look for good developers and not actually just look for good Rails people. Because it's ridiculous, like you see ads for, I want someone with 5 years of Rails experience. It's like you could get an excellent person who has Django, PHP, whatever experience, who will get model view controller, who can write tests, and they'll be able to work in Ruby and be effective in no time at all. I think that's actually another thing that's important to point out. It's like we embrace Rails, but I don't feel you know, like it's the best framework there is out there. I think that the important thing is that you're not inventing a framework and inventing your own tools, that you use best practices. And that's kind of like the biggest thing overall for us.
I guess Ruby is the best RPC mechanism there is.
Yes. It also allows you to run remote code with ease. You know. It shouldn't, but.
Is there a backend related reason why you have 4 input forms on the main side instead of just 1?
Yeah.
In short, because we can sell ads twice.
Yeah. It's actually an ongoing thing. I mean, there's some rules about like how the white pages and yellow pages have to be separated. This is something that, like, I think we're going to try to fix soon. So we're working on that. But clearly, it's kind of a UI fail.
Well, the story behind that is we have 3-year running contracts with our customers, and we come out of a world where there were white pages and yellow pages. And now, if you try to move that with 3-year running contract, then you have a problem. And since years, we know that this is a usability issue, but we're just not willing to lose half of the money from a business side. So there is no technical reason, but it's a business reason. But we're working on that.
By the way, I didn't mention in the talk that in the fall we launched a new search engine, which is very cool. It's all doesn't return XML anymore if you don't want it. It returns very nice, neat JSON responses, and this has been really great for us. We're now refactoring and simplifying the app, and it's nice to have a good, well-defined API in your company. That was something that also didn't exist until more recently.
How much effort was it, this graphing thing, to set it up? Is that something a smaller company can do?
I think,
You know how? Yes.
yeah, I mean, I was actually surprised at how much work it was. Part of the challenge was understanding all the pieces. Yeah, I was just going to say, let me get back to it. Okay, so basically, you have statsd, which is a server that's running, and it's accepting UDP traffic, and it talks to something that's called Carbon, which is basically kind of an aggregation engine, and it has its own database that's called Whisper. Part of the things that makes this frustrating to set up is that when you go to look at the source code on GitHub, it hasn't been updated in a while, and there's many people who have forked it and improved it, but it seems to be lacking forward momentum. But that being said, you know, with companies like Etsy and other people using it so heavily, it's very popular, but it's tricky. So even with something like statsd, you can choose like 3 or 4 different ways to collect the statsd. What also makes it a bit tricky is that you have many ways to get data into it. You can send data directly into a receiver or directly to Carbon on a TCP port, or you can send it to StatsD, which is going to do things like, for instance, if you just send stuff here, you're sending raw values. If you send stuff to StatsD, you can say like, I have a counter, or I have a gauge, or I have a timer. And it treats those things differently when it graphs it. So if you had an event that happened periodically, you'd want to have a counter, but if you were measuring search performance, you'd want to have a timer. Then these database files are kind of like RRD files. They get rotated out and collapsed over time and shortened out. Then on top of that, you have the actual Graphite web front end, which is Django with SQLite. And then you need to put something in front of that. In our case, we had Nginx, and we ended up using something called G-Unicorn, so we could run multiple processes that talk to Django. Figuring out all those components took me and Philip, who works in the integration team, probably about, I don't know, maybe 5 or 6 days working with one of the system engineers back and forth. And while we were doing it, sometimes we would get it set up, we'd start to get some data into it, and then something weird would happen, and we'd have to delete the file and try again. But then off of that, we wrote some of our own little tools, like Philip wrote these tools called grephlog that can follow a log and send values into Graphite. And then we had some libraries both in Java and in Rails that would ping Graphite and record responses. So there's also some new front ends. There's like something called Graffiti, which is a Rails-based front end. There's even some external services that you can use where you can sign up. The problem with that is that if you're doing high traffic, you probably don't want to be sending all of this data to an external service. So that was one of our concerns, which is why we spent the effort to set it up. But, yeah. Does anyone want to see Graphite in action?
Oh yeah.
Probably right over there. Okay, so here's Graphite. It starts out and you have this browser. This is part of where it also gets confusing. I see stats, stats counts, stats D. Like what the heck is that? It turns out that stats counts is when you're doing actual counting. So I can see how many times did somebody have an error with the free call system. Well, not very frequently. Or I could look at stats, for example. I'm going to reload. This interface is terrible, by the way. I highly recommend you use a different tool. These are gauges, so I can see, here's Unicorn, so I can see on this particular machine how many average requests are being handled right now, or over the last, it defaults the last 24 hours. And then how it works is you can add things up. And where it starts to get cool is I can say, okay, I have the average for one server, but I can edit this and say, just give me the average for all the servers. And now I get all the servers, and you can see, oh, I didn't get all the servers, I got some of the servers. Okay, here's Rails, oh, that's right. And then you can actually start to do things like you can add functions and stuff like that. So for instance, if I want to change the color or whatever, or the line, but I can also go into graph data and say apply a function like give me the moving average, and I'll take 10 data points, and it will do the adjustment there for me. And then I can say graph it all in a stacked graph. Maybe I want to see it all graphed up together like that. And then once you've got some neat things going, you can actually make a dashboard. And we've got a lot of different dashboards. Like for instance, here's one for our new search engine. We can see the request per minute, average response times, max response times, all these different kinds of things. Or you can do something like, here's our Rails dashboard that I showed in the presentation. So this is showing all the response codes, JavaScript errors, things like that. This is interesting too. We actually graph separately the bots, which we have a custom Python script that tries to detect what are bots and what are regular front-end people. And so we can see when we get a bot attack, which sometimes happens, we can see exactly where it's happening and what its codes are. When we launched restaurants, we separated it out so we could see this faceted search, how it was doing. And so yeah, we can basically see all the stuff in there. And so it's a pretty powerful tool. It's just really hard to use. Like I said, there's other things. Graffiti is nice because you can actually describe your graphs instead of clicking and dragging around. You can use little blocks of JSON. And this is really cool because you can check it into source control, and I think it's a bit easier to manage once you've actually figured out what you're doing. So I see us moving to something like this eventually, or a similar tool. There's a couple other options like it. So, yeah. What else can I say about graph? Yeah, it's great. It's a really cool tool for figuring this stuff out.
You use it well with Python, which is really useful because if something goes wrong, you see it within 30 seconds or faster. Like you can set it up to update every, let's say, 10 seconds, and you can instantly see if somewhere, somehow you missed the exception and the live traffic is hitting it, you immediately see an error code. So we had some of those, and then you can quickly do a rollback. So it is really useful.
Alright, everybody loves the homepage now. I don't think it'll matter.
You can move to 400s.
Yeah, that's true. Also, the 500s graph is a good one. Like,
1.0.
you really can tell. Like, a 503 is when your backend's not responding. A 502 means that unicorn is overloaded. That's the response code we get from Nginx. And the 500, of course, is an application error. So we graph them in different colors, so it's apparent right away, like, uh-oh, what's going on? And so, yeah, it does some weird things here. It kind of looks like art, actually. Yeah, exactly. So, but it's a lot of fun. It's a great tool. We depend on it pretty heavily these days.
So could you introduce us to the team so we know who to talk to
Yeah,
later?
sure. This is Jonas. Maybe you want to stand up.
Hey, I'm Jonas. I work as software engineer on the website. Probably mostly want to talk to me about the JavaScript stuff. Oh, I do know the Ruby as well.
I'm Thomas, and I work on the front end as well. And Eddie is somewhere there.
Yeah, I'm the new guy.
I work on front ends too.
You're all shy.
Server guys? Well, Yannick, who's...
Yeah, we are two from the backend development part, if you're interested in those things. It's me and Michael.
Keep us running.
Also, if you want to become one of us, we would still consider hiring you.
Yes, we have a jobs page on GitHub, actually. And actually, should I show off the castle?
Nice, please. Show off the responsiveness.
Oh, where do I go for that?
Local.ch.
Oh, yeah. Sorry.
The designer page designs. Oh no.
So I mentioned earlier that we've been working on this, basically like a design framework. So we combined a bunch of different tools like Zerb and some other things. It's SCSS. Jonas, maybe you can describe what it does.
Basically, we just stole together all the nice things on the internet and used them for our purposes. There's some really cool stuff in there, like the logo on top. Can you scroll up? It's actually when you're on the Retina display, we replace it with an SVG. It actually makes a ton of the difference. Like look at it on an iPhone and you see the difference. On a Retina MacBook, it's discussable. On an iPhone, you definitely do. The basic idea is that we have some reusable components for quickly prototyping things. So you can actually just throw up an HTML file and get it off without needing to do Rails.ch project. Ooh. Oh shit, I forgot to exclude active record. Let me start over again.
Exactly. It's also a nice way for us to like try to keep design consistent across all the various websites and things like that, which is always a challenge because if you've ever had to do that, like you end up with all these CSS and assets and things that have to be copied around and kept up to date. It's hard to keep them in sync between separate projects.
Thank you very much, Jeremy.
Yes, thanks.